So let's think about how to measure this physiological capability of a human. So that respiratory. So when we get to the hospital for health checkup, you may remember you have done this spirometer, which measures lung volumes in individual. So how do we measure it? It's very simple. We have a pipe and we can inhale and exhale. And these chambers record the amount of volume which is proportional to what our lungs are doing. And nowadays we have more electronic ways to do this. So when we are breathing, breathing is part of a voluntary and part of involuntary. So involuntary way, we normally breathe this inhale, exhale, while not paying attention. And that looks like a tide of the ocean. So this amount of volume, when we are not paying attention, we call as a tidal volume. So that volume change of the lung during our normal breathing. But also you can see when I have exhale, normal, but I realize I can exhale further. Let's do that. Till the end. So we can do this and then come back. Again, normal tidal volume. Inhale, exhale. And inhale, I realize I can inhale further. Let's do this. This is my limit. Okay, I can do this. And exhale. So this is our lungs capacity. Let's take a look. So our lung volume over time, this is normal tidal volume, which is about 500 milliliter. And I just did a forced inhale. So this is the limit I can do, and then exhale, normal tidal volume. And then while normally exhale, I exhale further, forced, this is the limit. So from this forced exhalation volume to the forced inhalation volume, and that we call capacity, vital capacity. So we define capacity as the sums of various volumes. And of course, even if I force my exhalation volume, there's some volume which I cannot handle, and that we call residual volume. So this one I cannot handle. So in this way, we can see from the real residual volume including and plus vital capacity is we can define as total lung capacity. And let's see. So functional, which means we can do this. So residual, when we have an exhale, so normal volume exhale, the amount of the air that's left inside the lung after expiration during normal breathing, there's this much amount that we call as during this functional and residual capacity. So functional residual capacity is really the summation of residual volume plus forced exhalation volume. So let's talk about ventilation. We're not talking about the ventilation of the air by opening the window, but we are talking about a breathing and physiology point of view. So ventilation is the exchange of air between the lungs, or particularly alveolus, and the atmosphere. So there's two phases of ventilation. First, air has to move into our lungs by inspiration. And then after this, we have to expire by moving the air out of the lungs during, expiration. So let's assume the flow rate is linearly proportional to pressure drop. So when the air flows in and out, this is a fluid movement, And we have to consider about the driving force. Driving force of the fluid is usually pressure difference. So that comes as delta P, and that pressure difference will cause the air to flow. So that flow can be represented as a flow rate here as V, a dot. Dot means a differential with respect to time. So the volume flow rate, and that there's a proportionality constant, which is we call as a resistance, meaning that for the same volume flow rate, the higher this proportionality constant, the higher the pressure difference we need. So this is R, and this R is the resistance to flow and the pressure drop. So to understand this better, we have to pay attention to the units. So the pressure drop as a millimilli Hg, you can use all other kinds of pressure such as a Pascal, atmosphere, but this is just an example. And the volume flow rate is a liter per minute. And then you can automatically know what are the unit of this resistance. So let's define the pressure difference, which is a driving force. This can be measured from the outside of the air to the inside alveoli, because we're considering the inhalation. So then the pressure is better to higher outside to inside. So that's a good definition. And then let's define the flow rate. When it comes positive is in, and when the flow direction occurs in the direction of decreasing pressure, that's more favorable. So that we call flow rate as a positive sign. And this is very similar to what we know from basic electrical engineering or circuit theory. So that an electrical circuit, you remember, probably heard about Ohm's law, which is related to the current flow with respect to the voltage difference or potential. That is driving force as an electrical potential. And if they go through a resistance, then those electric charge flow is defined as a current. So voltage difference is driving force, and that drives the current to flow, and that's proportional to electrical resistance, such as in this circuit. So here you can see the current is proportional to the driving force, which is voltage difference, but inversely proportional to the resistance. So the little the resistance is, the more flow with given the same potential or voltage difference.